we have learned how to define material properties for different countries. In this lecture, if user wants to model a material that is not available or pre-available in the ETABS program, what he has to do is that we need to go to define material properties. We left click on add new material. We again select user or material type as steel. Material type is very important. That is whether user wants to model a steel property, concrete property, aluminium, cold form, rebar, tendon, or masonry. Further options are directly dependent on this option. So we left click again on steel. Now here material type is already now defined as steel. We can name this material name as, for example, steel trial. What exactly is the difference between isotropic and orthotropic? Orthotropic means that the property is different from different axes. That is, material property can be different in one axis, it can be different in two axes, or it can be different in three axes. Not only modulus of elasticity, but shear modulus also, coefficient thermal expansion also, and Poisson ratio also. So if user wants to model an orthotropic material, it has to be done very carefully, because this option, and this option are dependent on each other by a simple empirical formula. So we left click on OK option. As steel is an isotropic material, we select specify weight density. Weight density of steel is usually 78. Modulus of elasticity is usually 2 into 10 to the power 5. Poisson ratio can be 0.3. Coefficient thermal expansion can be, for example, 0.12. Notice that this option and this option is grayed out, because if we enter weight per unit volume, mass per unit volume can automatically be calculated. Modulus of elasticity, Poisson ratio, coefficient thermal expansion, shear modulus here. Notice that shear modulus is also grayed out because shear modulus is also dependent on Poisson ratio and modulus of elasticity. After that, we go to design property data. Here we see 350, 400, 450, 500. Material name is steel tile and material type is steel isotropic. We left click on OK option. We can also enter non-linear material data. Hysteresis type can be either elastic, kinematic, takeda, pivot, concrete, BRB hardening, degrading, or isotropic. Parametric can be stress strain curve can either be parametric or user defined. If you select on user defined option, this whole stress strain curve data window will open, in which we can easily change the data. For example, if we change it as -400, -450. Notice that this graph automatically changes. Or either we want to, if select more number of points, we can click on add row. We can select on 0.2. Graph now automatically changes. We can now click on OK option. Material damping properties can also be entered. Right now we leave it as empty, and then we again left click on OK. So steel tile now is available. After that, if we want to enter a concrete user property, what exactly is the difference is that in the previous window for steel there was yield strength and tensile strength, but for now concrete it is concrete compressive strength FC dash, which is the cylindrical strength. So again we define it as, for example, 30 MPa. Weight density is can be entered as 25. Notice mass per unit volume automatically changed. Modulus of elasticity can be entered. Non-linear material data window can be entered. Stress strain plot is now predefined. If user is modeling a new material property, he has to enter each and every data carefully. He has to see and he has to observe that all the data he has entered has to be correct. So we left click on OK option. So this concrete is now available.